Hello everyone. Welcome back to the good stuff we've been doing. Okay, let me fix this. In the previous video, the area of the, we are okay, yeah, we did about no, this is not a pen. We did try to find the largest angle and got 100.8 degrees. In this video, we're going to find the area, but before then I would like to say something. You may be asking, okay, what if we are asked to find this angle A here? Or what if we ask to find angle B? Well, then the situation is still the same, because if this is the triangle where this side is C and then C, baby here is A and then B, and then we will have A and then B here. Because I said C square is A square plus B square minus 2AB cos C. It's not just the last case. If you were maybe looking for angle A for say, then the formula would then be A square. This side A square will then be C square plus B square minus 2BC, then the cosine of A. So you can get cos A when you know B and C and A. And also if you are looking for B, of course, using the same pattern, B square will be, it will be A square and B square. Then we don't subtract 2AB, then it will be cos B. So you don't even really have to memorize these three formulas. Just one, knowing one is enough. And also the pattern is clear. Just write the Pythagoras theorem and then subtract the 2 multiplied by the AB minus the cosine of the C part. Yeah. So yeah, of course, if you wanted to get angle A, you could have just used the formula for this A square here, this part here, and just plug everything. The old situation is the same thing like the previous one. Here we're not going to bother with angle. We are going to get the area of this triangle, and this area of this triangle is another problem to us, and I'll show you why. Let me clean the board. The area of this triangle is a problem because this triangle is no longer a right angle triangle. Of course, obviously, if the triangle was say right angle like this, no, that is not a right angle triangle. This should work. Come on. It's refused to show me right angle. You can literally draw anything and Microsoft will give you a right angle triangle. But somehow it's no longer working here. Okay, let's see. Maybe I'm not drawing it straight enough. I might use my ruler, but we have no need to. Oh, no. Okay, let's see. This won't work. Okay, let's manage this one. Okay, let's say, assume we have a right angle triangle in this case here now, where maybe this side is A and then this side is B and then this side is C. This area of this triangle, we can get it by half the height. Let the height here be H, the height times the base. Let the base here be, let the base be B. Height, the area of the triangle is half times the base times the height, or half times the height times the base, anyone you want to. But then here the triangle is no longer up, the triangle is no longer a right angle, is now obtuse. But there is a way we can remedy this. I will show you how. Now suppose then that we come here, say now this is the triangle that we want to find the area of. So this triangle here, then here this angle here might be, or this angle here is obtuse, say like one of the angle is obtuse. What we can do is to just drop a perpendicular. So I assume that from here to here we have a 90-degree. So because we know how to find the area of a 90-degree angle, we now try to find the area of a 90-degree angle here. So let's say this is, let's just part label itself A, this part B, and this part C. Then the area of this triangle will be the area of this triangle X and this triangle Y. Let's say this part is triangle X and this part is triangle Y. So that would be, for the triangle X part here, the area would then be, if this side is the height H, let's say this is small x, this distance is small x, and this distance is small y, then the area of this triangle big X is half times the base times the height. Like the base is X, so X times the height. What is the height? The height is H. And the area of the triangle Y, if we add it to the area of the triangle Y, which is half times still the base, still the height, they have the same height H, and the base is Y in this case here. So here H is in common, so this is half of the H, X plus Y. So of course X plus Y here is just the side A, so this side A is X plus Y, so this is half of H, X plus Y. like this case here. But then the x plus y, we don't write this is half of h ah, or we may write ah. So the area of this triangle is half of ah. But then this h here, in this triangle here now, if we don't know the h, we don't know the h here, but we know the a, which is one of the parts, which is 12, but we don't know the h. So obviously this formula cannot work for us here when we don't know the height. We don't know the height, but I will find the height in a different way. Notice that cosine sine of b, sine b will be the height, which is the h, that is the opposite of a hypotenuse. Hypotenuse will be this side c, this side is c, so this is over c. So h will then be c sine b if we multiply both side by c. So this formula, the area of this triangle would then be equals to half of, instead of h, we now write c sine b. So we have found the formula for the area of a triangle here, and that is half of. So let's see. Having discovered the formula, the formula for the area of, formula for the area of the triangle, we are going to apply it here. So if this is the triangle here, it says that the formula for the area is half of, let's say, AB sine of this angle. So it says half of AB sine C. So in this case, the formula is half of A is 10 times 12, that is B. Sine C is sine of 100.8 degrees. So when we plug it in our calculator, like if you use, this is half of 10 is 5, so 5 times half of 10 is 5, so 5 times 12 times sine 100.8 degree. If you compute this in your calculator, you should have something like 58.9 degrees, no, not degrees, 58.9, not 58, that is 59. But what I have here, my calculator is 58.9. So that is centimeters squared, since it's area. So this is the area of the triangle here. And remember what we did here. Always, if you want to find the area of the triangle, when the triangle is obtuse and not a right triangle, say the triangle, no, that is not a pen. So say this triangle is this way. If this is the case you have here, and this is obtuse here, then this is A, this is B, and then this is C. The area is, this is part C, so this is half of BC, or AB sine C, half of AB sine C, or BC sine A, whatever. So that is AB sine C. After plugging the 12, 10, 12, and sine this, we got this. But then for those who know about one formula, there's another way we could have done this without suffering like this, and I will show you. The formula is called Heron's formula. I think Heron's formula or Heron's formula. I think that is just it. It says that the area of the triangle is denoted by S or H is equal to square root of, you have something like small s minus A, then you have a S minus B, and have S minus C. Why I like the formula is that it's actually easy to remember. You just put S, then you put S minus A, S minus B, S minus C. But then S is not that too hard to get. S is just equals to A plus B plus C. Then you divide everything by 2. That is the value of X. So this case here is 12, here is 10, and here is 17. So X for this case will be 10 plus 12 plus 17, all divided by 2. So yeah, this is 22, 39. So that is 39, all divided by 2, right? So this is 10 plus 12, that is 17. No, that is 22 plus 17 is 39. Yeah. Sometimes I don't really know how to do the addition actually. So there's 39 divided by 2, that should be 19.5. So that is 19 and a half, I believe. So that is 19.5. So that is X. So what do we do about S minus A? Well, one of them is A is 10, A is 12, not A, B is 12, and then C is what do I say? C is 17. So even we don't even need to know whether A is 10, A is 12. We just pick this s and subtract one of them. So first of all, the s minus a should be 19.5 minus 10. So that should be 9.5 really. And then x minus b should be 19.5 minus 12. So that is we'll take away 19 from 12. We're getting 5, Abby. Yeah. No. That is 7. So 7.5. So if we say s minus c, then we'll be having 19.5 minus 17. So if you take away, that is 2.5, Abby. When you take away 17 from 19, you get 2. So that is 2.5. So the formula, the area is just s, which is 19.5. Then we multiply by s minus a, which is 9.5. Then we multiply by 7.5, and still we multiply by 2.5. So if we use calculator, we just I will do this in the calculator. So let's see. You can just try it on your own. We have a square root. Then we have 19.5. Okay. Then we multiply by 9.5. And we're multiplying by 7.5. And I also multiply by 2.5. So everything here gives us, there's no point in writing this square root again. So everything here gives us 58.9 centimeters square, which is exactly what we got. So this is called Hero's formula. We don't really need to know the sign of this angle to get the formula for area. And if you know this formula, it's not too difficult to memorize, but and is to prove it, you need the law of cosines. It can be proved, but there is no point in doing so. It will be an overkill. If the proof is too long to be included here, but I'll still do a separate video on it to prove this nice formula, simply because I like the proof a lot. So, but if you know the formula, just s minus s is just a plus b plus c over 2. So once you can just put this, you can get the area of any triangle you want to get. Like this computes the area of a triangle. So you don't even need to know the angle at all. You just need to know these three sides, and you're able to get the area of that triangle. So that is all for this II. So in the next video, we're going to go work on the B part of this problem. So thank you for watching, and please subscribe to the channel. Have a nice day.